Okay, so this video is going to tackle about the whole idea of Boolean algebra and um, like a bitwise operation. The thing is, like, this is not part of your syllabus or part of the course at all, but like you will be using this a lot in later classes. Like, for example, in your 2506, when you're working more with assembly, and later there will be something called like multiplexer or stuff like that. This is more useful if you're going to the side of the systems rather than in CS, like electronics and stuff like that. But this is a good shortcut, and it kind of makes your life easier when you have to deal with like binary, like algebras that deal with binary, like Boolean algebra and bitwise operation and all of those, especially in your CO7. If you understand this concept, it's going to make your life much easier. Okay, so a few concepts you should know about and understand better, or like get it in your head, is basically not, and, or, and XOR. That's it. That's all you need to know. These are, well, you don't even need to know the XOR in general, but like these are all the ones you need to know for what we're going to do, like what sort of like shortcut I'm going to show you. So yeah, let's get started. So just a quick refresher. So for not, it's basically going to do is like this, a, and in case of not a, it's just going to be the reverse. In bitwise operation, it's basically this. Okay, so if a was 0, it's going to be 1. If a was 1, it's going to be 0. This one, a and b, I'm really sorry about this. So a and b, right? So the idea is basically in terms of like a and b, the idea is if there is any 0, the answer is going to be 0. So over here there's a 0, so the answer is 0. Over here there is 1 0, so answer is 0. If there is another 0, 0. There is no 0 in this case, so it's a 1. And when you are working with like bitwise operation, it is an ampersand sign. Okay, so in C, this is how you do AND. For OR, if there is at least one, its answer is going to be 1. Otherwise, it's going to be 0, like this one. This is how you write it in C. So this is basically the bar. The bar basically means OR, okay? And XOR, which is this, the caret sign. And that's why many of the students use like tried pow and put caret. This is why it won't work, because in C the caret sign basically represents XOR, and the idea of XOR is basically they are going to be 1 if they are opposite of each other. So that's basically the basic of bitwise operation, or like in Boolean operation in general. So the shortcut I'm going to show you is going to be using not, and, or, these three. You will be needing these three. So let's take a look at this, a NOR. So this is not exactly like OR. I mean, like it's basically the opposite of it, right? So you can do something like a, or, and do a not, and this becomes NOR, right? For XNOR, this is basically opposite of this, right? So you can do something like this, and it's just going to work. The idea is over here is very simple. You just look at it and you're like, okay, I can totally convert this from this. But the idea, like this doesn't work when you have like too many variables, or like too many um, changes based on what type of binary number that is. And that's the whole idea of multiplexer. I'm not going to get into multiplexer in general. I'm just going to say like it's some topic you will be seeing in your next semester. But the idea is when it's small, it's easy to understand. But what happens, like what can you do when there's like way too many binary numbers or way too many digits you have to take care of? In that case, we use a Boolean algebra, like we combine some of the stuff, and I'm going to show it to you. Again, this is not part of the course, you can totally skip it, but if you understand this, your CO7 is going to be totally a cakewalk. Okay, so let's get started. So I was saying something like, what if you have like too many numbers to deal with, right? So for example, I have this truth table, okay, and this is going to be your answer. For example, it's E or something like that. Okay. So yeah, like for example, you have like these cases. Mm, and so on. Like usually what you want to do is write a whole truth table where you are writing down all possible cases. You know what, I'm going to do that instead of just saying it. So for example, you have to deal with like for let's say 3 digits. Okay, like sorry, 3 variables. Let's assume you have to work with like 3 variables at the same time. So it's going to be A, B, C. Okay, it's going to be A, B, and C. And the first thing you should be doing is writing down the whole truth table. Okay, so I actually wrote down the whole combination of zeros and one in case of like 3 of them. And if you like understand binary clearly, you can see that they are basically representation of 0, 1, 2, 3, 4, 5, 6, 7. Okay, so these are the possible cases that may arise, and we have like some sort of like variable that we want to like represent using this A, B, and C. Okay, so for example, imagine that it becomes 1 in these cases only. Okay, and rest of them are going to be 0. So you have to write a Boolean expression in a you have to write a Boolean expression which um, always ends up with this truth table. And the question is, how are you going to do that? You can force it all you want, like make all sorts of combination and all of those. That's totally fine. You're totally allowed to do that. But the whole point of this video is to give you a much easier version of it. Okay, so if something like this happens, like if you have to deal with a at least like 3 variables or 4 or 5, and you don't know like how to figure it out, like what sort of Boolean expression to come up with, so the what you can do is like use this small shortcut. Okay, so in cases like this, what you should be focusing on, where it goes 1. Okay, so these are the cases where it is 1. The first step is to identify that. Then what we are going to do is make a Boolean expression of them. So the idea is whenever there's a 0, you write that as a not. Okay, so I'm going to write it like this: A, B, C, because 3 of them are zeros, so I'm going to write them with not. You combine them with and. This is for this one. Next, you do it for this one. So in this case, this is a 0, right? So I'm going to write not a. These are ones. So you do not put not before them. Okay? Then you do this. Now the last one over here. In this case, none of them has any 0 on it. So you just write them down one by one. There you go. Now, these three are the expressions of these three. You combine them by doing a OR. Okay? And that's it. This whole truth table can be represented with this Boolean expression. This is going to be like, literally, this is always going to end up with this one. You can give it a try, try all of these combinations, and you will see that it works. And for now, I would say just go with this. You do not need too many optimization. You will be learning that in the later courses, but like, this is going to help you a lot with your CO7 assignment, like if you understand this. Unless you are totally free to do however you want. This is just something I am just giving you an idea of, because like in the previous semester I actually had to teach this to some of the students because it's not actually taught in the class. But like, this is a nice tool to have, and if you learn it now, you are going to ace your multiplexer assignment in the next 2506. So yeah, that's it for this video, and that's it for the bonus contents. From the next week, we are going to focus on the assembly, like how assembly works, how the address space works, how the registers work, and how you can convert your C into your assembly, and how to understand assembly in general, because your assignment of binary bomb is going to be based on assembly. And if you want to learn hacking, assembly is your friend. So yeah, that's it for now. I will see you in next week, or not see you,